elimination algorithm, and we need to give the description of all the hypotheses, well, both general and specific, which are consistent only. Okay. So what does our algorithm say? So the candidate algorithm mainly computes the version space for generating the hypotheses that are consistent. So how to make sure that the data that is given are consistent? Like in our finders algorithm, we used to calculate only the positive examples, taking them as the input and giving the specific generalized the output for the particular training data set. Whereas when we come with a candidate elimination algorithm, we are going to consider the negative training example as input, but we are going to make that negative example as a positive example based on some of the hypotheses that have been generated. Okay. So when it comes to that category, so what is the first step? First step is initializing the G to the maximum general hypothesis. So that is G, capital G. Next, initialize S to the set of maximum specific hypothesis. So let me take the condition G equal to, so G generalized means in bracket all the data will be of question mark. Okay. So how many attributes I'm having? I'm having 6 attributes. So what happens? I'll be having 6 generalized attributes for generalized hypothesis or maximum general hypothesis. So when it comes to specific hypothesis, what I will have? I will have a null set, okay, which will be represented by 0. Okay. This is my first step. So what's the next step? I need to check the examples, training examples. So if it is a positive example, what I should do? Before this, let me tell you what are inconsistent data. Inconsistent data are nothing but whatever the training examples will have negative or no conditions in which do not satisfy the training function or the target function. Those are called as inconsistent data. But we need to make sure that that inconsistent data should be made as consistent based upon the hypothesis or based on the general hypothesis. Now what happens if suppose if there is no data set or empty data set is there? So that is also an inconsistent one, but we cannot take that data as input because when there is no data, what happens is whenever if you perform any hypothesis, the general hypothesis remains all question mark, the specific hypothesis remains all null set or 5 symbols. Okay. So now what I will do? So this is my first category. Okay. So if D is positive example, what I should do? Try to remember only the first category. Okay. Then the second one is very easy. So
you have not shared the screen.
I have shared the screen.
No, sir, it is not coming. I don't know. For the others.
Hello. For others, are you getting the screen?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Okay. The spider framework is the screen that I'm sharing right now. Okay. I'm explaining the algorithm part. So what I should do, if it is a positive example, I need to remove G, any hypothesis inconsistent with D. So what is my training data set? This is my training data set, first instance. Okay. So do you have, and it is positive. Yes means positive state. Okay. So what is my G naught state? G naught is, or G condition is question, or G is question mark. So what happens? I'm going to type G naught equal to, so whether this data, these 6 attributes in the first instance are less general to this, this is more general, whereas this is less general. That means if you have question mark, that means I can take any value. So what happens? Do I want to change this G naught or should I retain the same thing? So what happens? This remains same. Okay.
Retain.
You have to retain this because there is no changes, right? So what happens? This data remains same. So this is G naught. So what happens to S naught? S naught is nothing but that it is a positive data. So when it is a positive data, what I should do? I should apply find S algorithm. So what the initial data set is in the S. This is my first iteration. Okay, this is my this is first iteration. This is default for the initial data set, initial value hypothesis. So what happens to the S naught? Earlier I'm having null set. Okay, whereas I'm getting this data as an instance now. So whether you are having a data set which is empty is better, or do we have, or we are having the specific data is better. Having a data is better, right? So what I will do, I will copy this data here. Like I'm going to write only the first word, sunny, warm, normal, strong, comma, warm, comma, same. So this becomes my first hypothesis for the positive state. That is what it is explained here. So remove G, any consistent one. So there is no inconsistent data. So what happens? No need to change for G hypothesis. And for each hypothesis, yes, that is my small instance here in capital that is not consistent with D, remove S from S. Right now there is no inconsistent data. So what I should do? I should retain the same. Okay, as I am having the empty set. Whereas in the second category, I am going to remove the inconsistent data. That means whenever the data is going to change. So what I should do now, add this data to the hypothesis where I need to make them as minimal generalization. As in my data in the earlier step, as I have had empty data set, so I have taken the minimal specific hypothesis for this. Okay. So that becomes a consistent example for the given training instance. And sometimes what happens, there is a particular condition and some member of G is more general than H. And we need to check once again the general hypothesis. When I compare this S naught with G naught, what happens? This G naught is more general than this naught because I can take any values in G naught, whereas in S naught, these data are the must. Okay. So that is what is explained in this condition. If the condition doesn't satisfy, then what I should do? I should remove that. Sometimes I need to remove those hypotheses that are not or more general than the specific hypothesis. This will be the third instance we will get. Okay. So that is for the first iteration. That is for the first instance. Now what happens? I go with the second instance. So what is my second instance? This is my second instance. So second instance value target result is also function is also yes. That means it is positive state. So what I should do when it is positive, remove from G any hypothesis inconsistent with D. So what's my earlier hypothesis? G naught, it's having all question marks. So what happens to G1? As there is no data, so what happens? This thing remains same. Got it? So as it is more generalized already G naught in the first category for the first instance, no need to, and for the second instance also it is positive, no need to do any changes as it is already more generalized when it compared with this following instance or for the second input instance. Okay. Whereas when we come to S naught or S1, what happens? I need to check the earlier hypothesis. What's my earlier hypothesis? I'm having Sunny as the first input instance. When I compare with the second one, both are same. So what I should do? I should retain this as it is. Next, what is my second instance? Warm. Earlier instance is also warm, so there is no change. Okay. Next, when I compare third attribute, earlier I had normal, whereas in the second instance I'm having high. So what I should do now? What changes I should do in this? When the data is getting changed in the instances, what I should do? I should make it as generalized. So what I will do? I will make it as question mark. Okay. Next, when I compare the fourth instance, it is strong, no changes. Fifth instance, for fifth attribute, no change. Sixth attribute is also no change. So what I will do? I will retain the same as it is. Yes, W, yes. Got it? So this is my second iteration. Now this is the most important one. Listen carefully before. So now I need to take G2 instance. Okay. So before categorizing G2 instance, I need to check the instance now, whether the instance is a positive instance or not. So when I compare this instance, it is not a positive training example. I'm having negative. So what we will do in finders algorithm, we are going to neglect it. We are not going to take it as input. We are going to retain the earlier specific hypothesis as the output. Whereas, listen. So if we are checking the data set or instance, it is a positive example? No. So what I will do, that means it's a negative example. So the one important thing in the candidate elimination algorithm, if you learn this first one, replace capital G by small s, capital S. Wherever we have small s, replace it by small g. Okay, it is nothing but general hypothesis. So as it is a negative example, what I should do now? I should remove from S any hypothesis inconsistent with D. So what is my S state now? This is my S state. This is my instance. Okay. So do you want to remove, as it is a negative instance, so what I will do for specific? Do you want to remove this? Yes, because it is a negative instance. When we apply find def algorithm, what we will do, we will going to remove that inconsistent data. Okay. So what happens now? In specific S2, so what I should do? I should remove this instance. I should not consider this instance as my output. So what happens? The earlier input or the output, what I'm having in specific, that remains same. Okay. Whereas, listen now. After this, I need to make it as generalized because as it is a negative example, in candidate elimination algorithm, I need to make this inconsistent data as a consistent one. So what I should do now, for each hypothesis G in G that is not consistent with D, what I should do, remove G from G. So what happens now? See here in the G1, I'm having all question marks, whereas here I'm having rainy. Okay, but I should not consider this data as my input. I need to get the complement data of this input. So this is the most important condition where we are going to generate the version spaces. Okay, so this is the shortcut method. Whenever we have a negative instance, we need to make it as positive by considering the complementary values of the possible given data set. As I'm having the sky values only two, sun and rainy, so what will be the complement of rainy now? It is sunny. So what I will make it as first as yes. Whereas when I consider this input as or this feature as my important feature or attribute, so I should neglect these remaining five. So what happens? The remaining five becomes question mark. Got it? So this is the.
Hello, sir.
Any doubt
Hello.
here?
Hello, sir.
Hello, yes, Vishnu.
Sir, some people are waiting. You should let them in, and they are saying.
Yeah, I already let them. Only Shreya was there.
Okay, sir.
Okay. So this is the most important one. When my instance is negative instance, what I should do? I should consider the complement values, possible values, and I need to make it as more general. So this is first category, or this is the first instance. Similarly, what I should do? I have got first value rainy, so the complement value was sunny. So I have changed it. Now the second instance is cold. So this is, so what happens? The first attribute will become generalized question mark. Okay. Whereas my second attribute, I'm having cold. So it is a negative instance value. So I need to make it as positive instance. So what happens? What is the complement values of this cold now? It is warm. So what I will do, I will take it as W. Next, when I'm considering this value as my input, so the remaining five attributes remains question mark. Once you got this, the output will be very easy. Okay, you can see the output in the easy step. Got it? So this is my second general hypothesis. So this is G0, small G0. The second one is small G1. So the next one, I'm having high. Okay. Whereas here, I'm already having high in the remaining attributes. So no need to do any changes. Whereas the fourth attribute, it is strong. Do I have any possible values for here? No. So no need to change for this. I'm already having warm here. So already I'm having warm in the other two instances. No need to change. Whereas this here, in the change, the last attribute, I'm having same as the positive instances. So what I should do now, I should get the positive instance of the input now. So for change, what will be the complement input? Same. So what I will do, the last general hypothesis will be question mark, comma, question mark, comma, question mark, question mark, question mark, comma, what is the value? Same. Yes. Got it. So this is the general hypothesis for the negative instance to be made as positive. So these values are your version spaces. Okay. Any doubt till here? Okay. So that is my positive instance. So I have removed the G from the general hypothesis and I have had all the minimal specializations of H such that H becomes consistent. Now this data is consistent compared to the earlier specific hypothesis. Okay. So no need to change anything. So if there is any more specific, what I should do, I should remove those general hypotheses which are less general. Right now there is no concept as it is as the obtained hypotheses are more generalized compared to the specific hypothesis. No need to remove it. Okay. So this is for negative instance. Negative instance to positive instance. Got it. So now, what is the last category? Fourth iteration. So I need to check the instance. So the instance is positive, yes. So what I should do, I should make it as more generalized now. Okay. So let us go to the algorithm. So if D is positive example, remove from G any hypothesis inconsistent with D. Do we have any inconsistent data in G? Yes, we have one. That is your last category. So see here, in this general instance, this is my inconsistent one. Why? Because already we have the data in the instance that is same, right? So when I compare with the positive instance, the earlier instance, here it's already generalized. The last value is already generalized. So this instance will be removed. So this data becomes an inconsistent one. So what happens? At last, I will get G3. So that is the general hypothesis is equal to what I should retain. I should retain only these two because these are consistent data compared to the new hypothesis. Okay. So after removing those data which are inconsistent with the instance, so for each hypothesis, specific hypothesis that is not consistent with the what I should do, remove S. So when I want to take S3, so I need to check the earlier instance. Earlier instance, what I had SW question mark, SW question mark. So that is Sunny. So when I compared with the instance Sunny with this value instance, so there is no change. So what I should do, I should retain as it is. Okay. Next, I'm having warm in the specific earlier specific instance. I'm having warm, so no need to change. Next, I'm having high, whereas I'm already having generalized hypothesis in the specific find S algorithm. So do we want to retain this question mark or the value? I need to make it a generalized one. So what happens? This value also becomes question. Next, I'm having fourth attribute value as strong. In the specific instance also I'm having strong. So there is no change. Next, in the fifth attribute I'm having cool, whereas in the earlier instance I'm having warm. So there is a value or the values are changing. So what I should do? I should make it as generalized. So that is what is said here. So when this becomes condition, I need to remove those inconsistent data by making it as minimal generalization to the specific hypothesis. So what happens if I do that condition? At that time, the G will be more general when compared to the S. Okay. So next, I'm having change. Here I'm having same. So there is a value change. So it becomes question. Got it? So this is the workflow of your program. How the execution, this has been explained in the theory class also. I had already taken the class in the last Thursday. So I wanted to warm up this data once again. So I have explained the concept. If you have any doubt till here, you can ask me now.
Sir, I couldn't not understand this high normal column C
Okay.
ಅಲ್ಲಿ ಚೇಂಜ್
Ah,
ಮಾಡಿದ್ರಲ್ಲ ಥರ್ಡ್
yes.
ನೆಗೆಟಿವ್ ಇನ್ಸ್ಟೆನ್ಸ್ಗೆ ಹೈ ನಾರ್ಮಲ್ ಇದೆ. ಹೈ ಇದ್ದಾಗ ಅಗೇನ್ ವೈ ಡಿಡ್ ವಿ ನಾಟ್ ಟೇಕ್ ನಾರ್ಮಲ್ ನೆಗೆಟ್ ಮಾಡಿದಾಗ
Yes,
ಅಂತ?
yes. ಕೇಳ್ತೀನಿ ಹೇಳ್ಕೊ. So in the third instance, right? So in the third instance, see here, after getting the second value, the third value is high. Okay, in the instance, whereas I need to check the other attributes which I'm having high and normal. Both values are there. Okay. When I compare this data, which data is having more weightage?
ಹೈ.
High. So what I should do? I should neglect the normal. So this you are going to study in the next algorithm. Okay. So this data becomes an inconsistent one, or this attribute becomes inconsistent. That means this attribute will be having a negative impact. That means we should not take that as a attribute value, important value for prediction and all. Got it?
Yes, sir. Thank you, sir.
So those data are called as inconsistent attributes. Okay. So see here you can take the snapshot of this. I'll send the data also. Okay, take the snapshot. Once I execute this, you should get this output. So these values I should get as my output at the last. Have you seen this? Shall we execute the code?
Yes, sir.
Okay. So that is what I told. And do you want me to explain the coding part? So whatever I explained here, the same thing here. We are going to take the data as numpy, as np, pandas as pd. So I'm going to read those data from my CSV file. The only important thing is you need to understand the concept of iLocation. Have you read this in your Python? What it stands for iLoc?
Index location.
Yeah, it is index location, or sometimes it is called as integer location also. To get the integer location of the array data. Here itself I have given the data also. If you want, you can learn this. Okay. We have studied this index of iLocation of 0 means it's going to give the first row of the data frame or the instance. Data frame is nothing but instance here. Okay. 1 means it's going to give second row. If I give -1 means it is going to give, whereas array you used to get the last value. As the data is in the form of rows, what I will get last row. Okay. Similarly for columns, if I want to get column, I need to make the row value as first column, comma 0, first column, 1 means second column, -1 means last column. And iLoc of 0, 5 means first 5 rows. So colon of 0, 2 means first 2 columns. This is what we explained here. Same thing here. You need to understand this concept. If you want me to explain this, do you want me to explain? Because this remains same. Earlier we had this concept in finders. This was not there. So I need to make it a generalized one. So what I will do like this. So what I will do, I will take a data and I'm going to read the data from row. All the rows has to be read. I need to read the columns from initial 0 to end column. Okay. So those are my concepts, right? So that is what we are going to discuss in the candidate elimination algorithm. So those are nothing but concept learning. So that I'm going to print it out. So I'm going to take the target value. What will be the target value? The last column value. So this value will be my target column. As it is, I need to take positive or negative instance. So I'm going to take this value to -1. I'm going to print the target values. I'm going to write a function. So I'm going to take specific hypothesis as 0 because I cannot write a 5 symbol. So what I will take 0 and I'm going to print the number of copy item that I am having. I'm having 6, so I'm going to 6 0. So initialization of specific and generalization will be done, and I'm going to print that. So how to write the general hypothesis? I need to take the input as question mark for the I 0 to range is equal to length of specific. So what will be the specific hypothesis? I'm getting 6. So the range for question mark will also be in the form of 6 question marks. Okay. So once it is done, I need to go to the looping start. If the target instance is yes, I need to make sure that it's positive, and I am going to check the range. If it is positive, and I am going to check if h of x, h of 0, this is my first hypothesis, not equal to my specific hypothesis, that is your question empty state. So what happens if they are false? So what I will do, I'm going to make it as general. If it is true, I need to make it as specific. This is for positive instance. Similarly, for negative instance, you can see the code. The specific hypothesis will be replaced as it is here, making it as general. This line here, it is not there. Whereas all the other things are going to be present the same as it is. Okay. So once you apply this candidate elimination algorithm procedure, what we did here, I'm going to write the number of candidate elimination algorithm steps it's going to take for execution. How many number of steps I should get. So I'm going to print that. Once it is done, I'm going to check the indices values. That means that all the indices I'm having the same values. If I'm having 6 attribute indices, I should get the 6 attribute indices as the output. And sometimes what happens, I need to remove the data values. Sometimes when the data is an inconsistent one like this. So in this third instance, I had removed this inconsistent data because it's not an important factor when I compared with the earlier more general hypothesis. Okay, so what I should do, I should remove this. So this thing will be done here. General hypothesis will be removed, those who are having the question, or that is nothing but inconsistent data. Okay, once it is done, I'm going to make them as specific final and general final as the word variables, and I'm going to call the learn function once again. This concept is going to iterate once again. So I have told for only one instance. This repeats for all the other instances also. Once it is done, I'm going to get the specific and general hypothesis as my output, which will be separated by new line. Okay. So execute. Okay. So when I execute this, you can see here. See what's my output. How many number of values I'm getting. Okay. I'm having sunny, warm, high, strong, warm, normal, and I'm remaining values are being taken. Why? Because I have done some changes here. So these values are also being read. Wait, I will remove. I copy this data to some other page. Did you saw what was the problem that I did? I had executed the code in the same sheet, so I had got the result as different one. Okay. So now we will execute it. See, now we got the output. So I'm going to read the data, and I'm going to make it a specific and general hypothesis. So what happens for the specific hypothesis, the first instance remains same, whereas the remaining 3 instances are question mark. So if I take the positive state, what happens? I'm going to apply candidate elimination algorithm. So I had earlier question mark. So what happens? I'm going to take this as my input. Now, if it is negative instance, so here I had already this data, so I have taken only first attribute. So because this is an important attribute, here I'm having second important attribute. There was a change. Whereas the earlier remaining instances are question mark. And you can see at the last we have got the inconsistent data when I compared with the third instance. So in the third instance we had what value? Warm, but already we had the warm here. So no need to change. Sorry, change here. This is the value. I'm already in the change. So what I should do, I should get the complement. Whereas here they're having equal proportionate values. Okay, so what I will do, I will be taking the, usually the conceptual wise, what we should do is we should get the complement value of the negative instance. That's it. As I'm having only two values here, there is no problem. If I am having three or more values, at that time I need to get the changes, or I need to take the entropy and the information gain value for that to classify it. Okay, so that we will be studying in the second module under decision. So once it is done, so it will be applied to all. What will be the last final output? You can see a specific hypothesis, this one. General hypothesis becomes this. Got it? This will be the last. See here, you can see here the general hypothesis only I'm having two hypotheses. The first one only and the one. Okay. Any other doubt? This is what your second algorithm or second lab program. If you have any other doubt, you can ask me, or else we can end up the class.